In activity 1.8, we're given a function s of t equals negative 16t squared plus 16t plus 32 to model the height of an object as a function of time, or a balloon in this case. Now, first part A asks us to sketch a graph. Probably the easiest way is to label a couple of points. Because we're going to be working with the graph, I've already created it here so that we can do some of the things that we need to do with it. So first off, it says compute the average rate of change on the time interval from 1 to 2. So we're going to compute the average rate of change, or in this case it's an average velocity, from 1 to 2. So that's going to be s of 2 minus s of 1 over 2 minus 1. Now, s of 2 is equal to 0. S of 1 is equal to 32. Those just come from putting those inputs into our function. Over 2 minus 1, which is 1. So we get negative 32. And now our units on this negative 32, our output was in feet, our input was in seconds. This is negative 32 feet per second. Now, in case you're wondering why it's negative, well, let's look at what's going on. At 1, we are right here. We're 32 feet in the air. At 2, we're right here, 0 feet in the air. And we can see that there's a negative slope. Our height is decreasing, so our function value is decreasing. So our average rate of change should be negative between 1 and 2. So on average, our balloon is descending at a rate of about negative 32 feet per second between 1 and 2 seconds. Part C asks us to use the limit definition to find s prime of 1, or the instantaneous rate of change at 1. So we're going to do the limit as h approaches 0 of s of 1 plus h minus s of 1 all over h. Now applying that to our function, we get the limit as h approaches 0. S of 1 plus h is negative 16 times 1 plus h, the quantity squared, plus 16 times 1 plus h, plus 32 minus s of 1, which we calculated earlier, which was 32. All over h. Now multiplying this out, one of the most common mistakes is to rewrite this as 1 squared plus h squared. This has to be FOILed out, and when you do, you'll get 1 plus 2h plus h squared plus 16 times 1 plus h, and then these will cancel, and we'll continue from here. Now we haven't taken the limit yet, so we should still be writing it out front. Limit as h goes to 0. Now let's distribute. We have minus 16 minus 32h minus 16h squared plus 16 plus 16h. Those 16s will cancel. Kind of skipped putting it over h there. And now we've got the limit as h approaches 0. Negative 32h plus 16h is going to give us a negative 16h minus 16h squared all over h. Now what I'm going to do in that numerator is I'm going to factor out an h. So I have the limit as h approaches 0. And you could factor out a negative 16, but the most important thing is factoring out the h, because I want to get some cancellation. So that's what the h factored out of each term. All over h. Those cancel, which now allows me to solve this limit via direct substitution, plugging in 0 for h. That makes this whole part 0. And I get left with negative 16. So that's my instantaneous rate of change at 1 second. Once again, this will be in feet per second. So at 1 second, the height of the balloon is decreasing at negative 16 feet per second. So we have an instantaneous velocity at a point instead of average velocity over an interval. Now let's take a look at how these look graphically. So we have our 2 points over which we found the average rate of change, which gives us a secant line between those 2 points. So using a ruler, we might draw a secant line that looks something like that. Now, at s prime of 1, we have what we call a tangent line, and it's going to hit at that 1 point and mimic the slope of our graph at that point, and it will look something like this. So we have a line for each, and notice how much steeper our secant line is than our tangent line. Well, that makes sense because the height is decreasing faster at 2 than it is at 1, and so calculating the average is going to give us a steeper slope than just calculating the instantaneous rate of change at 1. Now for part E, for what values of A do you expect S prime of A to be positive? Well, they're going to be positive for any place where the balloon's height is increasing. And that didn't start being launched until time 0, and then here until about a half a second. So in this interval, in between 0 and 0.5 is where we would expect S prime of A to be positive. From 0.5 to 2, we would expect S prime of A to be negative because the height is decreasing. So there's one place right there at exactly 1/2 second where we'd expect it to be 0. We can see it would have a horizontal tangent line, and that's where S prime of 1/2 or 0.5 is going to be 0. It's the one place it goes from increasing to decreasing. That place where it changes is a place where our derivative has to be 0, and we're going to see as we go on that's going to be a really important concept in dealing with derivatives.